Okay, thank you, everyone. Our next contributed talk is Truthmaker Semantics for Justification Logic by Daniele Sansoni, who just graduated from the University of Florence.
Well, hello, everyone, and thank you very much for having me. Thank you to all the organizers of this wonderful conference. A few caveats. The necessary premise of the presentation that I am about to give to you is that it talks about a work in progress, and as it happens with quite a lot of works in progress, there are things that are in flux, and there are open issues, and even more fascinating direction to put this research into. So what I would like for everyone to take out of this talk is why it is interesting to bridge justification logic and truthmaker semantics, and why maybe, just maybe, subset semantics could be the key for unlocking this very likely liaison that, as of now, has not been realized. So, also, I am quite new to the truthmaker semantics environment. I come from a proof theoretic education, and would like to have as much as input as possible from all of this. So, let's get this started. If it can start. Yes. Well, what is justification logic? Well, justification logic is a quite recent technical endeavor. The first system was proposed by Sergei Artyomov in a technical report in 1992, and then later published 1 year later in a collection of proceedings. And the first system was known as the logic of proofs. And it has quite the link with intuitionistic logic, as we are going to see. But nowadays, justification logic has developed as a field of research in its own. And, well, it mostly deals with epistemic logic, formal probability, and deontic logic. And formal probability is the closest to its original aim, if you will, for justification logic. And from a technical standpoint, the most important syntactical category of justification logics are justified formula. And they have this general shape here. That is, T justifies phi, where phi is a formula and T is a justification term. And so this is the main syntactical category that we'll be dealing with. Justification logic is mostly at a propositional level. So these are the only terms we're going to deal with. Now, why justification logic? That's a good question, and it requires explanation. Justification logic has been developed originally by Artyomov to account for an age-old, not age, but, logic in its modern inception is quite modern, and for an old philosophical dream by Kolmogorov that was also taken in stride by Gödel, if you will. And the main idea was to supply an interpretation of BHK semantics in which the notion of proof was to be understood classically and possibly in a formal environment. And as we all know, Gödel provided and conjectured, really, in 1932, the conventional embedding of intuitionistic logic into what was going to be known as model system S4. The problem was that S4 could not be linked with any formal theory of mathematics because, well, we would incur, as you can see, in a violation of, Gödel's second incompleteness theorem. That won't do. So, Artyomov presented the Gödel's impasse in such a manner. We have intuitionistic propositional calculus that embeds into S4, but we have no way of linking S4 to classical proofs. And Artyomov's solution was to deploy the logic of proofs. And we do have an embedding result between S4 and the logic of proofs, and this is known as the realization result. And then we have a way of connecting the logic of proofs to Peano's arithmetic. And this is known as Artyomov's arithmetical completeness. And what is interesting to notice, because history is funny and we need to account for it, is that something very similar to justification logic was to be found in Gödel's note for a lecture in 1938 made to, it was hosted by an affiliate of the Vienna Circle, Zilzel. And funny thing to notice, it was published for the first time in 1995, and that is the year where, for the first time, a fully fledged justification logic system was advanced by Sergei Artyomov. Now, we talked about justification terms and justified formula. These are how justification terms are built. There is a set of justification variables, and each of those is a justification term. Then we have justification constants, and each of those are justification terms in their way. Then we have operation symbols. We do have quite a lot of them in justification logic, but most widespread are the plus and the application, so the small dot, and they are used to combine and construct more complex justification terms. There are also different ones, and we're going to talk about those later. You're going to find out why. In any case, they're used to account for different actions. Now, these are some examples of formula of justification logic. The first is just belonging to classical logic, and most of justification systems are built on a classical framework. Then we have justified formula. Then the third example is a justified formula by a more complex justification term. And the fourth one is more interesting because in justification logic, we allow nested justifications. So we have V plus W justifies T application X that justifies phi if and only if psi. So nested justifications are in the play here. There are many different systems of justification logic, and well, they're mostly based on at least the one we'll be dealing with in my Truthmaker Semantics approach, on a classical basis. So we have classical tautologies. Then we have these two little axioms that are mostly shared, and they explain the meaning of the function symbols, if you will. The first symbol, it really is a form of way of accounting for modus ponens, and it is quite intuitive from a knowledge standpoint, because suppose that you have a reason for a conditional, then you have a reason for the antecedent of the conditional. If you combine them, if you put them together, then you have a reason for the consequent. So this is also interesting, considering how Truthmaker Semantics approaches notion as, well, the problem of logical omniscience, because we're not dealing with logical omniscience here. It is very similar to, of course, model scheme K, but we are not stating that we know all the consequences of what we know. We're stating that there are reasons for the consequences of what we know. They are based on the reasons for what we know. And the consequences, also better, the reasons for the consequences are more complex than reasons about the things that we know. So it's just about taking account this complexity. And the second axiom, it really is a form of weakening at the level of terms, if you can take a look at it. So, justification terms, what do they stand for? They stand for, originally, proofs or reasons for stating so and so. And we have, well, constant and variables. Variables, of course, stand for arbitrary justification, and constants stand for, well, things that are not further analyzed and are mostly, in a way, to empower the deduction power of justification logic. They're assigned to axioms of the system through a methodology that is known as constant specification. And, well, there are different constant specifications. We're not going to deal with those, but they often correspond to different ways of approaching something epistemically. For example, if your constant specification is void, then you're dealing in an epistemic round with a totally skeptic agent that has no way of accounting for anything in its axiom systems. And also there is this thing to notice that is known as internalization properties. So justification logic is able to account for its own justification. So if you have a constant specification under certain requirements, then you can prove that if the justification system proves phi, then for some justification term of some form, the justification system can prove V justifies phi. And this is funny and interesting to notice. And what's the relationship with model logic of all of that? Because we talk about embeddings. Now, justification logic, and this is the first step towards considering Truthmaker semantics for justification logic, as I'm going to explain, well, can be considered an explicit counterpart of model logic. Because if you really think about it, model formula like box phi express, for example, phi is known, or phi is proved, or phi is mandatory, but do so without providing a reason for that, without accounting for it. And this information is codified in justification logic and through justification terms. And in general, justification terms are truly just a, if you will, structured, tracked version of the box operator. Substituting occurrences of the box operator within the model system is the way for building justification systems. And this is a general procedure that I talk about. It is understood as realization. And realization results do not only obtain for model companions of intuitionistic logic, but also for all the model logics of the normal standard cube, and also for the infinite logics, model Gitch logics, the funny logics with the interplays between box and diamonds in the conditional. So we do have, if you will, model companions of, for example, intermediate systems or intuitionistic logic. Then we have justification counterparts for model companions. There is this double embedding, if you will. Now, this is the wrong crowd to explain what Truthmaker semantic is, of course, but what I would like to stress is that the Truthmaker semantic account is able to provide approaches that are quite similar to some solution of justification logic. For example, by Saita has been constrained for Truthmaker semantics for approaching non-idealized knowledge, and non-idealized knowledge for normal and non-omniscient epistemic agent is something that is studied in justification systems, and also practical reason by Professor Feroldi, just to state a few things. Now, this is a quite, I think, notorious, one would say, way of presenting the hyperintentionality problem by Creswell. Is just the standard way of presenting it, but we're going to take that information about how Creswell construe these kind of things, and instead of the posing of the question by Creswell, we're going to notice how he answers it. And because this is interesting for how hyperintentionality is construed in justification logic, because justification logic is hyperintentional. In what ways? Well, if there are logical equivalents in justification logic, then, well, we can prove that the same justification term justify both sentences. So, if you will, justification logic is hyperintentional at the level of terms. And if you take a look at the relationship with model schemes, well, while we have model schemes that are valid in the normal model logics, their justification counterpart scheme obtained through realization. So, if you substitute box operators with justification terms, they're not. And a common explanation by that, by Artyomov and Fitting, is that, for example, in an epistemic environment, justification logic is able to account, for example, when you're dealing between phi and phi, for the cognitive effort to distinguish these two and to understand that phi and phi is a redundant phrasing of just phi. Now, let's get to our first, if you will, objective target from a philosophical and semantical standpoint, that is, well, of course, possible word semantics. Because there is possible word semantics for justification logic, and these are known as fitting relational semantics, and they are quite similar to, well, the possible world cryptic models, but they are embellished with an evidence function. So that is a mapping from justification terms and formula to possible worlds. And they are employed for providing conditions for justified formula. So let's take a look at it. Then, considering what I said about the relationship between justification terms and box operator, I think it would be unsurprising to notice that the first condition is model. So it's just a plain model condition in the most, well, universal account of the box operator. And then we have the evidence condition, that is, the word must belong to the mapping of the term and the formula. And what is interesting about the intuitive reading and not so intuitive about the fitting semantics for these systems is that the evidence function states that in a possible word W, T is relevant evidence for the truth of statement phi, but this is nothing more than a syntactic approach, because it could also be read, and this has been noticed in the literature by Lemon, for example, considering how the evidence function interprets terms as sets of formula that they justify in a particular world. So if you will, and if you take a closer look at it, at the evidence function, we don't have a true semantic counterpart for terms. And let's get back to Creswell, because this syntactic approach has been, in a way, has been revendicated by the likes of Artyomov and Fitting. And Creswell proposed a solution to the hyperintentionality paradox, how he called it in the 70s, through taking into account the syntactic form of, well, the sentences. So it has been advocated, of course, Creswell's account is a bit complicated. If I'm not mistaken, it took into account Lewis' notion of meaning, but without dealing with that, what is interesting to notice is that it has been advocated that justification logic accounts of hyperintentionality mostly at the syntactical level. So we're dealing with justifications for formula statements, but not for proposition, if you will. And this is the alternative. And it is going to be the first stepping stones in building a Truthmaker semantics for justification logic. And this is subset semantics. Subset semantics still belongs to the family of possible word semantics. And it is a tuple, as you can see. And we have a set of words, and we have an empty set of normal words within this wider set of words. Then we have, of course, the evaluation function that, of course, it spouts out truth values from out of formula. And then we have an assignment, a mapping, if you will, of terms in words to set of words. So in the subset approach, we do have a semantic counterpart, a true semantic counterpart for terms. And these are sets of possible words. And this is the subset clause for justified formula that is quite different from the one in fitting semantics. So first thing to notice, normal possible words are important for this clause. And we have that for each word belonging to the set of normal possible words, the evaluation function of the justified formula at that word, well, it will say it's true if and only if if you will, the meaning of the term and that particular word, so a subset of word, is a subset of the set of words where the evaluation function states that the formula, the justified formula, is true. So, to put it bluntly, as Lemon would say, the semantic is called subset semantics since we define that T justifies A holds if the interpretation of T is a subset of the extension of A. Slight misuse of the word extension, I would say, but because we are dealing with sets of possible words. But there are two things to notice. That firstly, while being a possible word semantics, subset semantics is not really a relational semantics, I would say, because there is no accessibility relation, but we have a subset relation mostly dealt with in the assignment of terms. And through placing constrictions on this mapping, we obtain different justification counterparts of model schemes. Also, this is something interesting to notice, that while hyperintentionality is a given in the fitting syntactical semantics environment, it needs to be earned using non-standard evaluation points in the subset semantics. Of course, by Professor Jaeger, it's been, well, famously stated that normal words are important for modeling hyperintentionality. And this is quite apparent in subset semantics, because if you take a subset model where you have only normal possible words and you take two, for example, actions, they are true at all normal possible words. And therefore, the set of possible words where phi is true and, well, the set of possible words where psi is true are the same. That is the entirety of W. And each subset of phi of the sets of possible words where phi is true better is also a subset of the set of possible words where psi is true. And therefore, well, thanks to the subset clause, each justification term T that justifies phi will also justify psi. And we are losing hyperintentionality here. Now, this is a philosophical argument that was, in a way, the first stepping stone for me to think about these kind of things. And it is Jaeger's argument that he deployed while dealing for Truthmaker semantics for relevance logic. Professor Jaeger noticed that in relevance logic, we want to avoid the following paradoxes for material implications. And therefore, we must consider them, this couple of formulae, if we will, invalid. There must be evaluation points where they fail. Still, we want, in most of relevance logic, the law of identity to be valid. And in the stronger relevance logic, also to have the other principle valid. So we come to an issue. How can this fail on some evaluation points and yet be valid? And of course, if taken into account as a technical issue, well, it is easily solved. We employ non-standard evaluation points. And we define validity only in regards to standard evaluation points. Yet the philosophical issue remains, noticed Professor Jaeger. So why should we disregard non-standard evaluation points as counterexamples to validity if they could count for producing counterexamples for inferences or a conditional? So Jaegers' proposal was, of course, employing truthmaker semantics for a variety of reasons, and, for example, dealing with the law of identity and the included middle, well, to deploy the null state. Now, Jaeger's argument applies for subset semantics. This is what I believe, and it is quite apparent because justification logics that deploy subset semantics are built upon a classical framework. There are whole hyper-intentional extensions of classical logic, if you will, and we deploy non-standard evaluation points. And although all of this, all the meaningful clauses provided by Professor Studer and Lemon on formula of terms for subset semantics, be then on the evaluation function or the meaning of the terms, if you will, are just defined for standard possible worlds. And so validity is only defined on classical worlds. And of course, we are falling deep into Jaeger's argument. And very sneakily, we provided quite a lot of reasons for providing a truthmaker semantics for justification logic. The first is quite blatant. The justification logic is hyper-intentional, but fitting semantics only provides a true account for the syntactical interpretation of the hyper-intentionality, if at all, because I find it quite hardly explicative. Subset semantics for justification logic provides a non-syntactic explicative approach to hyperintentionality. And I say it explicative because if you pull out impossible worlds, you lose hyperintentionality. You put them in the framework, you have them. But they are, the subset semantics model, vulnerable to Jaeger's argument that is philosophical in nature. And moreover, the third element, as I stated, justification logic is an explicit counterpart to model logics, and it strongly hinges on the notion of aboutness. We have explicit proof representatives instead, if you will, of just boxes in a formal probability sense. So this got me thinking. There are two ways to approach a truthmaker semantics for justification logic. And, well, the first is the one that we're going to explore, once again, the first steps. And it is top-down. So provide a subset-inspired bilateral, because it's more to my liking and I know more about it, truthmaker model for already known justification systems. Then we have a bottom-up, so build a truthmaker semantics endowed with an exact clause for justified formula, and study the resulting justification logic systems. And I have singled out a class of systems that are probably more susceptible to this approach because they are the one that have been proposed by Lemon and Studer when they first advanced subset semantics. So they'll L star CS, because we're dealing with constant specification, and LA systems. I mostly dealt with the L star, at least so far. So how we do it? First, there are a number of strategies, and there is the proposal of semantic counterparts to justification terms, because we don't want to incur in the same mistakes of the fitting semantics. So justification terms will be interpreted as states, or rather, considering the inspiration provided by us to us by the subset semantics, as sets of states, indexed, moreover, to particular states. So we will advance a mapping that takes in input a couple made of a state and a term, and it spouts out a subset of the set of states of the, of course, general set of states that is part of the model. And then we have a proposal for an exact truth maker, false maker, quite a lot of proposals really, clauses, if you will. And we're going to take a closer look at the different clauses and how they relate to different approaches and how these approaches are similar or dissimilar to the original subset and, if you will, possible word approach. One thing to notice from a philosophical standpoint, as it was also pointed by me reading, that it was pointed by me by Professor Giordani, but I already had a grasp on it thanks to one of his papers. Well, this approach interprets a set of states as both justifiers and verifiers. So whatever we intuitively consider states to be, they are taken to be something that can play both, if you will, an ontological or an epistemic role. So they just provide a variety of functions, if you will, in this approach. Now, this is the first proposal for an exact verifier and then falsifier for justified formula. And the proposal is mostly subset in its notion, because we have that S is an exact verifier for T justifies phi if and only if the meaning of the term at that particular state is a subset of the set of truth makers of the justified formula. And the notion of falsifier is blatantly, simply it is not a subset. Now, as you can notice, we only deployed the notion of subset. So, using for all the terminology, we are only proposing flat clauses, and universal at that. And flat clauses are referred as so because they account not for the parted relations between states. And on the contrary, if one were to deploy structured clauses, also the parted relation will need to play a role in all of this. And also, this is something that I just, if you will, brainstormed with Professor. There is also an alternative exact false maker clause. And this is as follows. So it just makes reference at the presence of, within the meaning of the term and that particular state, of a state belonging to the set of false makers of phi. And of course, as we know, the same state can both verify and falsify the same formula, but this does not happen in the environment that we have chosen. So that is of classical worldly state space. This is the environment that I chose for this first iteration of the Truthmaker subset models. And I think that outside of such boundaries, this clause would work better and would be more convincing for a general approach to this kind of matters. And I probably need to speed up things. These are some structured ideas for, structured clauses for justified formula. And as you can see, we're keeping the spirit of the subset approach, if not the latter, because the containment relationship is no longer using subset theoretical notion, but rather the parted relationship. So S is an exact verifier for T justifies phi if and only if for each element belonging, for each state, of course, to the meaning of the term at that particular state, there exists a verifier, truth maker, such that the first state as first is part of as second. And of course, the exact falsifier is built in a speculative manner, if you will. And we can notice that, in the previous flat approach, we were only dealing with truth makers. Now we are dealing with something that is different. We can also account for just parts of truth makers of the justified formula when we are dealing about what are the conditions for the exact verifiers. A thing to notice is that for the structured clause to sound convincing, truth-making and false-making ought to be closed under parted relationship. That is because otherwise, state as first, that is a part of the verifier of phi, of the clause, could even be in itself a false maker of phi, and this would be quite paradoxical, at least. So there are ulterior conditions that need to be imposed, probably, or weighted properly, even from a philosophical standpoint, when employing these structured clauses. And this is also a proposal for a different exact falsifier for justified formula, in the spirit of the alternative falsifier for the flat clause. So, also, the meaning of terms is something that needs to be approached, but considering constraints of time, I would just say that it was a royal we, I deployed a set of states approach so that the output of the mapping of the terms is a set of states. Of course, this approach can either deploy set theoretic or lattice notion for its clauses. These are two alternatives down there. Between the flat, if you will, set theoretic notion of subset, and the second that employs a different understanding of the plus between justification terms in the meaning, that is, if you will, is the set of fusions of elements of the interpretation of the first term with the elements of the second, of the interpretation of the second term. Now, what are the strategies that I employed for this first iteration of the first route? And the first was to build back normal possible words using standard truth-making devices. So I will be the first one to concede that this is a hybrid account. as of now in this first iteration. If you will, the role played in the original subset semantics by non-normal possible words will be instead played by states here. And of course, instead of using an evaluation function, I deployed the relationship of an exact truth making into the possible word constructed into Truthmaker Semantics account. And also I adopted float clauses and meaning of term as set of states, because it was the closest to the original subset semantics approach. So, there are some preliminary notions. There are truth-making notion of modalized state space and classical wordless state space. I'm not going to spend time on those, of course. There are the notions about justification system LC stars, and just a little bit of those to let you understand what I was dealing with. Well, the LCS star justification logic systems are, of course, classically based. And they are, well, all the standard truth functional operators. The problem is, and the issue is with justification terms, because they are special. They deploy a special constant that is known as C star. And, well, C star is, we do have justification terms that are built in such a manner. And the meaning of this term is going to be quite clear in a while, because these are the set of axioms for these particular systems. And these systems, well, deploy, of course, classical axiom for propositional logic. Then we have a variance of the application axiom. As you can see, only for C star terms it applies. And we have no true distinction between the term of the antecedent and the term justifying the whole conditional, as it was in the original justification logic account for the application axiom. Then we have weakening. And as you can notice, And as you can notice, we have justification counterpart schemes or very well understood and known model schemes, because if you deploy the inverse operation to realization, that is the forgetful projection, as Artyomov talks of it. So if you substitute justification terms with box operators, you have of course, positive introspection scheme, so scheme 4. You have, of course, factivity with scheme T, and, well, you have a particular instance of it with bottom and so forth. Well, these are rules of inferences of these systems, and we have what is interesting to notice, instead of simply notice that it has modus ponens, is that it has axiom necessitation, and axiom necessitation is quite similar to necessitation in model logic, and you can see a different operator, that is the exclamation point. Exclamation point has been referred as proof checker in the formal probability environment, or fact checker. So the idea from an intuitive standpoint, and it is the idea of the scheme of factivity, of the scheme of introspection here, is that if you have proof of something, then you have proof that that thing is a proof of something, and then you can go on for all your axioms. So this is why we call this axiom necessitation, why we employ the exclamation point. Also, we have constant specification, but I already told you about them. And what is this first iteration of the subset Truthmaker of the subset Truthmaker semantics model? It's a tuple where we have these elements. We have a set of states of a state space, and then we have a non-empty set of possible words that is part of a classical wordless state space built upon, well, the state space of the model. And so intuitively, its elements are consistent and complete possible worlds constituted by ranging states. And once again, what we are dealing with are states that behave like world, but they are still states. So they can verify or falsify statements, as you all know, and they can be used as the part of the meaning of the terms. These are some of the constriction placed in this first iteration of the mapping of terms. And as I told you, the mapping of terms is really paramount here, because it's what, if you will, it construes the models for different schemes of justification logic. So we have a meaning of the plus operator. We have a meaning of the C star. And if that doesn't convince you, I share your feelings because, of course, as Professor Giordani noticed, we have the set of states that is closed under modus ponens. That is just the entirety of the set of states. And this is something interesting to notice for the further projects of this research development. And then we have, of course, the condition that makes references to verifiers of phi for the axiom necessitation shortly. And then these are the conditions that have been deployed for accounting for the additional axioms of the justification schemes that one can add to the standard three justification schemes that I talked about. So weakening that particular form of application, and then, of course, classical tautologies. And some of those are quite nice, quite interesting. Like, for example, if we are dealing with the scheme about bottom, then we have to prove that, there is a possible world, so states behaving like a possible world, that belongs to the meaning of the term evaluated at that possible world. Then we have for factivity this other condition, that is that the possible world where the evaluation takes place must belong to the meaning of the term, and so forth for the factivity. For the positive introspection, that is the third one. Moreover, these are, just the truth-making clauses that have been, we care for those only in normal possible worlds. They're quite standard. I've already talked about them, but what I would like to focus your attention on is that results so far. And the results so far are quite simple and are quite slim, I would say, even if somehow encouraging. So we have soundness of the model for LCS star logics using this particular environment. It's a simple proof by induction that shares a bit, but not in its entirety, with its subset counterpart. And we have, I'm actually dealing with the last few kings of the completeness. Yes, 5 minutes, of course. Well, in short, it seems that in exact falsification and flat-oriented TS subset models based on a classical Worldly state space are, they suffice for soundness and completeness for LCS star logics. Of course, the results gained so far are in the current iteration. I'm not really satisfied with those because Jaeger's argument is not mended. His issue has not been dealt with. We are still dealing with validities and accounting for them through a distinction between states and states behaving as possible worlds. And also, we would like to have, of course, this is somewhat deliberate, as I've written here, because this first iteration is the closest possible to the original subset approach. And then we have an exact approach to terms that it would seem intuitive, but the current iteration of the model uses mixed clauses, because sometimes makes reference to an exact truth making, sometimes just to the set of verifiers. So, if you will, it deploys exact truth making. So I would like to find a way to be more, to make it work better in the exact way. And these are the philosophical and technical aims that I would like to pursue once I begin my PhD, that is. And beside refining with new iterations of the subset Truthmaker Semantics model, firstly, I would like also to see if it can account for this other family of systems. And this other family of systems, they behave in a manner that is quite similar to standard justification logic systems because they don't have the C star constant. So they're more standard, they're more well behaved, but they pay this in complexity for the subset clauses. But they have also slightly different properties. But the point is, considering how the clause regarding the, if you will, behavior of the C-star operator in the current iteration of the model is a bit iffy, I'm curious if this means that I can, just simply and very easily annihilate, if you will, the C star constant from the language, and so get something closer to justification systems that employ standard justification terms. Then I would like to provide a philosophical account of the different advanced truth-making clauses, because they do deploy, sometimes they require different constriction, and I would like to see how they behave in a more general matter and try to provide, for example, epistemic accounts, because as I already told you, justification logic is quite apt in dealing with epistemic accounts, and also is responsible for providing, if you will, a revival of the, if it is a revival indeed, of course, of the knowledge as a justified true belief. Justification logic is able to account, for example, for the paradox of the of the prime minister by Russell. So it is able to differentiate between, if you will, knowledge-producing evidence and misleading evidence in a way. And this is the most important thing that I would like to also receive input from you. And I think it is very important and interesting to try and develop a theory of subject matters for justification terms. Well, they are, for example, in this particular iteration, they have been indexed, but in a way, considering what justification terms stand for, so proofs, or sometimes like mental awareness of an agent, if you take a more epistemic approach, what are some interesting properties that they could be closed under? For example, there have been proposals of closing justification terms. Of course, I'm talking about closed condition states and then see what they mean for justification terms. But for example, there have been proposals about closing justification terms under first degree entailment. I don't know much about them. Professor Ferroldi is quite skeptical, but something that can be developed. And also to begin the second way, the bottom-up approach. So produce a number of justification systems with a bilateral truth-maker basis and see where that gets me. And I think these are the references that I probably mangled, but I mean, so far, this is what I've done. Thank you.